Today, this video demonstration will focus on the parts and function of a compound microscope. Here at Makati, students can manipulate four kinds of microscope: the stereo or dissecting microscope, the monocular, binocular, and the trinocular compound microscopes. Stereo microscopes are generally used to inspect larger objects such as small mechanical pieces, minerals, insects, and more. It is designed for observation with low magnification, while the other three is generally used to view very small specimens or objects that you wouldn't normally see with the naked eye, such as prepared slides of microorganisms and tissues, and they are used for viewing samples at high magnification, which is achieved by the combined effect of the lenses. So this video presentation will specifically entail the different parts of a compound binocular microscope. Basically, the binocular microscope is made up of the following components. The main body, which is composed of the head, the arm, and the base. The head holds the body tube and the eyepieces. The arm is the part connecting the head and the eyepiece tube to the base of the microscope. It gives support to the head of the microscope, and it is also used when carrying the microscope. The base acts as a microscope support. Also carries the microscopic illuminators. The eyepieces, also known as ocular. This is the part used to look through the microscope. It is found on the top of the microscope. The standard magnification of the eyepiece is 10 times. The eyepiece tube, it carries the eyepiece just above the objective lens. It is flexible and can be rotated for maximum visualization. The diopter ring, it is useful as a means to change the focus on one eyepiece so as to correct for any difference in vision between your two eyes. Adjust the diopter ring to compensate for the difference between your right and left eyesight. The objectives, these are the major lenses used for specimen visualization. They have a magnification power of 4 times to 100 times. There are about 1 to 4 objective lenses placed on one microscope, and each lens has its own magnification power. For the scanner, 4 times. For the low power objective, 10 times. High power objective, 40 times, and the oil immersion objective or OIO, 100 times. The revolving nose piece, it holds the objective lenses. It is movable, hence it can revolve the objective lenses depending on the magnification power of the lens chosen. This stage, this is the section in which the specimen is placed for viewing. They can have stage clips that hold the specimen slides in place. So the most common stage is a mechanical stage. It allows the control these slides by moving the slides using the mechanical knobs on this stage instead of moving it manually. The aperture, this is a hole on the microscope stage through which the transmitted light from the source reaches the stage. The condenser, these are lenses that are used to collect and focus light from the illuminator into the specimen. They are found under the stage next to the diaphragm of the microscope. They play a major role in ensuring clear, sharp images that are produced with high magnification of 400 times and above. The higher the magnification of the condenser, the more the image clarity. The iris diaphragm, it is found under the stage of the microscope, and its primary role is to control the amount of light that reaches the specimen. It is an adjustable apparatus, hence controlling the light intensity and the size of the beam of light that gets to the specimen. The adjustment knobs. These are knobs that are used to focus the microscope. And there are 2 types of adjustment knobs. The fine adjustment knob, which is a slow but precise control and used to fine focus the image when viewing at the higher magnification for a sharper image. And the coarse adjustment knob, these are used for initial viewing, and it is a rapid control which allows for quick focusing. The microscopic illuminator. This is the microscope light source located at the base. It is used instead of a mirror. It captures light from an external source, either an LED or a halogen lamp. The stage controls. Stage controls allows the movement of the specimen's light in both y-axis and x-axis of the stage. The power switch. This switch is located on the arm of the microscope and turns the illuminator off and on. The brightness control dial. This is used to control the intensity, brightness of the microscope.